Okay, we're going to look at how structure affects acidity. So go ahead and put a few acids on the screen. Hydrofluoric acid, hydrochloric acid, hydrobromic acid, and then hydroiodic acid. So if I was to ask you which of these was the strongest acid, how could you figure it out? So actually there's a very logical way. So what do we know about size? If you look at all of the halogens present, of course they're all in the same group. And if we were to rank them from smallest to largest, fluorine would be your smallest. And then going down the group you would have chlorine, bromine, and iodide. Okay, so what size does as far as affecting acid strength, the larger your bond, the stronger your acid is going to be. Okay, and so why is that? So the larger your bond, electrons are not held as tightly between the atoms, and so it's much easier for a hydrogen to be released as a proton. It's much easier for the acid to give up a proton. So in this particular case, your strongest acid would be hydroiodic acid. Okay. So if that's your strongest acid, if hydroiodic acid is the strongest, which one would be the weakest base? Which conjugate base would be the weakest base? So the actually conjugate base that would be the weakest would be the iodide ion. Okay, so the stronger your acid, the weaker the conjugate base. Okay, so this is strictly going down a group. If you have acids composed of elements in one group, look at size. The larger the bond, the stronger the acid. So once again, it's much more easy, or easier I should say, for the proton to be given up, to be donated to another species. So now,